the last class, we were discussing about the distance formula in coordinate geometry for class 10th, right? So in this tutorial, we will discuss our second topic, section formula. So let's see. First of all, we need to discuss what do we mean by the section formula. So there are some different parts of this. First of all, if we draw a line segment, AB and P is any point on this line segment which divide this line segment into some ratio. So the finding the point P is called the section formula, right? So let me derive the formula for this. The first part of section formula is called internal division. We need to divide a line segment internally into some ratio. Let's see how to derive the formula. If we have a coordinate plane, coordinate axis, and A and B are any 2 points which draw the line segment AB. Let's consider the coordinate of point A at x1, y1 and the coordinates of point B at x2, y2, right? And consider any point in the plane, any point in this line segment at point P which divide this line segment in the ratio m:n. Point P is any point on the line segment AB which divide this line segment in the ratio m:n. So we considered the 2 points at x1, y1, this must be the numerical value, B x2, y2, this must be the numerical value, and ratio is also the numerical value. We need to find the coordinate of point P in terms of x1, y1, x2, y2, m and n. So we need to find the coordinate of point P in terms of the given A, B and the ratio. Let's see how to find. First of all, we need to consider this coordinate as x, y. Consider this coordinate as x, y. Now we need to find the value of x and y in terms of this given part. We will get the coordinate of point P. That will be the formula to divide a line segment internally. Let's see. To finding this one, first of all, we need to draw some perpendicular to find the length x1, y1, x2, y2, x and y. We don't know about what is x1. If we draw the perpendicular from point A to OX axis, this point we can say M. So we can say OM is the length which is called x1 and MA is the length which is called y1. So this length is called x1 and this length is called y1. What do you mean by x2, y2? We need to draw this perpendicular on x-axis, on OX axis. So this is, we can say, n. So we can say the length ON which is called x2 and length BN which is called y2, right? If we draw the perpendicular from point P, let's say this is PL. So we can say the length OL which is x and the length PL which is y. By drawing these perpendiculars, we can find some length. We can say OM as x1. This we can say x1. OM we can say x1. OL we can say x. And OM is called ON is called x2, right? So OM is x1, OL is called x, and ON is called x2. As well as on y coordinate, we can say MA as y1, and LP we can say y, and NB we can say y2, right? So this length is called y2, and along y-axis this is called y and this length is called y1, right? But we have to find the value of xy in terms of this. To find these one, we need to draw some triangles in this. So to drawing a triangle, we need to draw two more perpendiculars, the perpendicular A to the line PL, which is called AQ, and another perpendicular P to the line BN, which is called PR. So we drawn two more perpendiculars here. Perpendicular is called AQ as well as PR. So these are two more perpendicular. So how many perpendiculars are drawn here? We need to write here. AM is perpendicular to OX, PL is perpendicular to OX, BN is perpendicular to OX, and we drawn AQ is perpendicular to PL, and we drawn PR is perpendicular to BN, right? Very good. Now we need to relate these sides with X and Y. How to relate this? Let's see. Can you find the length of AQ, PQ, PR and BR? Yes. You know what is the length of AQ? This is called OL minus OM, which is called ML. OL minus OM, which is X minus X1. This length is called ML, which is equal to AQ. So we can say the length of AQ as X minus X1. We can also find the length of PR. So PR will be equal to ln on x-axis. We can write it as ON minus OL, which is x2 minus x. So this length is at x2 minus x. This is the length of PR. So we can say here, we can say the length of AQ, which is called x minus x1, length of PR, we can say x2 minus x. We can also find some two lengths as PQ and BR. Similarly, PQ can be written as y minus y1. So we can write it as y minus y1. What do you mean by BR? Which is y2 minus y. So this is called y2 minus y. Right? This is called y2 minus y. So now we have all the length at AQ, PQ, PR and BR, and AP and PB already given in the question M and N. So now we can relate these two triangles as a similar triangle. Why? Because you know, if two triangles are similar triangle, then ratio of their corresponding sides are same, right? So here we can say these two triangles are similar triangle. This is the perpendicular 90 degree and 90 degree. This angle is equal to this angle. This angle is equal to this angle by corresponding angle, because these two are parallel line and this is the transversal line. So these two angles are corresponding and these two angles are 90 degree and 90 degree. So we can say triangle APQ is similar to triangle PBR, right? Now these two triangles are similar triangles, so we can say the corresponding side AP by PB of both triangles will be equal to AQ by PR of both triangles, which is equal to PQ by PR of both triangles, right? So now we can say AP by PB, which means M by N. AQ by PR, we can say X minus X1 divided by PR, we can write X2 minus X. And PQ means Y minus Y1, and divided by PR means Y2 minus Y. We are substituting these values here. Now we need to find X in terms of X1, X2, Y in terms of Y1, Y2. So now we can equate these two. So we can say M by N is equal to X minus X1 by X2 minus X by cross multiplying, because we need to find the value of X is equal to Nx minus Nx1. You need to simplify this. It will be Mx2 plus Nx1 is equal to Mx plus Nx. In the right hand side, we can take x common. So it will be n plus n multiplied x. So therefore x will be mx2 plus nx1 divided by m plus n. So this is the value of x in terms of m, n, x1 and x2. You need to just cross multiply and simplify to find the value of x in terms of other value, right? Similarly, if you are equating m by n with this, you will get the value of y. So we can say m by n is equal to y minus y1 divided by y2 minus y. This will be my2 minus my, which is equal to ny minus ny1. Simplify this, my2 plus ny1 is equal to my plus ny. So my2 plus ny1, similarly as x, we can take y common here. So therefore y will be equal to my2 plus ny1 divided by m plus n. So this is the value of y. So now we found the value of x as well as the value of y. So now we can say the coordinates of point P. Therefore, the coordinates of point P are mx2 plus nx1 by m plus n and my2 plus ny1 divided by m plus n. Very simple. This is called the section formula. If you have 2 points are given, to draw the line segment, take any point P in between which divide this line segment into some ratio like 2:3, 3:1, 1:2. You can find the coordinate of point P. So two different type of question can be asked in this topic. First question, to find the coordinate of point P, and the second question, if all the 3 points are given, to find the ratio. So these two are very important questions in this section formula, right? So let's see how to find these things. We have some different parts of section formula also. This was the first part of section formula, which is called the internal division. So let's see, if we have a question, find the coordinates of point P which divides the line segment joining A 3:1 and B 4:2 in the ratio 2:1. In the ratio 2:1. So here you can draw a rough diagram like this. The coordinate of point A at 3:1, point B at 4:2. And we have a point P which divides this line segment in the ratio 2:1. We have a line segment joining 3:1 and 4:2 and take a point P which divides this line segment in the ratio 2:1. We need to find the value of P. We need to find the coordinate of point P. So let's see, here we have x1, y1, we have x2, y2, and we have m and n. We can find the coordinate of point P by the formula. You can say point P equivalent to mx2 plus nx1 divided by m plus n and my2 plus ny1 divided by n plus 1. Right? So the coordinate of point P No need to remember this formula. Just try to understand the concept how to substitute the value. Here mx2 plus nx1 means you have to multiply this ratio with opposite side x coordinate, this ratio with the opposite side of x coordinate and divided by m plus n. So this will be equal to 2 multiply 4 plus 1 multiply 3 divided by 2 plus 1. What about the y coordinate? 2 multiply minus 2 plus 1 multiply 1 divided by 2 plus 1. It will be 2 multiply minus 2 and plus 1 multiply 1 divided by 2 plus 1. Right? So you can say the coordinate of point P as 4 to the 8 and plus 3, 11 by 3, and minus 4 plus 1 minus 3 by 3, it will be 1, sorry, minus 1. Minus 4 plus 1 is minus 3 by 3, that will be 1. So this is the coordinate of point P. This is the required coordinate of point P. 11 by 3 comma minus 1. Right? By this way you can find the coordinate of a point P, coordinate of any point which divide a line segment in some ratio. Right? Now, this is called the internal division. Now the second part of section formula is called external division. Let's see second part, which is external division. Right? If we have a line segment AB, A x1 y1 and B x2 y2. So what do you mean by the external division? External division means point P is just outside this line. Point P is just outside this line which divide it into some ratio externally. So let's see, if point P is outside the AB which divide the line segment in some ratio, we can say AP is to PB and M is to N. So what will be the coordinate of point P? So here, after deriving the formula as we derived the formula for internal division, it will be mx2 minus nx1 divided by m minus n and my2 minus ny1 divided by m minus 1. Just we need to put the minus sign in the place of plus sign in internal division. This will be the external division of the line segment. Right? Now the third part of section formula, which is midpoint theorem, midpoint formula. Right? Midpoint formula. With the help of this formula, we can find the coordinate of midpoint of a line segment. Let's see, if we have a line segment A and B joining AB, its coordinate is given x1 y1 and the coordinate of point B as x2 y2. Right? Coordinate of point A is x1 y1, coordinate of point B as x2 y2. We need to find the midpoint P, the coordinate of midpoint P of this. So if P the midpoint means we can say the line segment AB divided in the ratio 1:1. Divided in the ratio 1:1. Then we can say P is the midpoint of AB. Right? So the coordinate of point P we can write mx2 plus nx1 divided by m plus n. You can say mx2 means 1 multiply x2 plus 1 multiply x1 divided by 1 plus 1. Finally, we can write it as x1 plus x2 by 2. In y coordinate, 1 multiply y2 plus 1 multiply y1 by 1 plus 1. It will be y1 plus y2 by 2. We can apply this midpoint formula directly to any question if you have to find the coordinate of midpoint of some line segment if both end points are given. This will just x1 plus x2 by 2 and y1 plus y2 by 2. Right? So these are the external division and midpoint formula we can apply in the question. And the fourth and the last part of the section formula, which is called the centroid of the triangle. The last part, which is centroid. Centroid of a triangle. Now let me discuss what is the centroid and how to find the coordinates of centroid of a triangle if all the three vertices are given. Let's see, if we have this triangle ABC whose coordinates are given as x1 y1, x2 y2 and x3 y3. x1 y1, x2 y2 and x3 y3. These are the coordinates which is given. We have to find the centroid. Now you know centroid is the point of intersection of medians of the triangle. We can draw three different medians from vertex A, from vertex B and from vertex C. The point of intersection of all the three medians is called the centroid. The point of intersection of all the three medians, which is called the centroid. So, and centroid divides the median in the ratio m2:1. We can represent the centroid at point G. This is called centroid. And centroid divides each and every median in the ratio 2:1. If you draw this median, this will again 2:1. If you draw this median, it will be again 2:1. So the centroid divides every median in the ratio 2:1. So we have to find the coordinate of point G, which is called the centroid. So to find the centroid, we need to find the coordinate of point D. Since AD is the median, so D must be the midpoint of BC. Since AD is the median, so D is the midpoint of BC, and you know by midpoint formula the coordinate of D can be written as x2 plus x3 by 2, x2 plus x3 by 2 and y2 plus y3 by 2. Now consider this AD as a line segment, and to find the coordinate of point G, we divide this into 2:1 ratio. So both points are given, both end points are given, and the ratio is also given. We can find the coordinate of point G, which is centroid. So by the section formula, we can write it as 2 multiply this plus 1 multiply x coordinate divided by 2 plus 1 with the help of section formula. Now applying section formula in the line AD, you can say the coordinate of point G as mx2, means 2 multiply x2 plus x3 by 2 and plus 1 multiply x1 divided by 2 plus 1. And in the y coordinate, same as you can write 2 multiply y2 plus y3 by 2 plus 1 multiply y1 divided by 3. So the coordinate of centroid will be, you can cancel 2 with 2, 2 with 2, it will be x1 plus x2 plus x3 by 3, x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 divided by 3. So we can say the coordinate of centroid of a triangle, if all the three coordinates are given, we can just add the x coordinate and divide by 3 and just add the y coordinate, divide by 3. This is the formula to find the centroid. Right? So these are all about the section formula: internal division, external division, midpoint and the centroid of the triangle. We will discuss some application based question in the next tutorial. And after discussing the application, how to apply these formula in the question, we will discuss the area of the triangle. Right? Thank you.